Hello. Voxel week continues. I did not pre-announce the stream very far in advance. I apologize for that. Um, so, I think what we'll do today is we'll start with an overview of what the project is, which is redundant for most people, but you know, we get new people occasionally, so do that. So I want to wait just a little bit longer for people to show up. Although I guess that's the new people. I guess I should do the overview like halfway through. That's when people will have shown up who aren't familiar with it. Probably nobody who's here doesn't know what the project is. Who's here now? It's so confusing how that kind of stuff works. Yeah, we barely have any viewers right now. So yeah, I don't know what the best way to deal with that is. Yeah, maybe I'll save that for partway through. So maybe like in an hour or two, I'll do a reminder overview. Well, there is this here. Let's move this up a little. This is the bit of text. I don't have a bot set up to answer questions and stuff. So there's this. It's a very hacky system right now for choosing what meshes to create and freeing the old meshes. So I think I want to tweak that. Although also maybe I want to do Frustum culling. I guess we should do Frustum culling. Rig log Frustum. So we need Frustum planes to clip against. And we can do that by projecting into projection space. But the better thing to do is to work backwards from projection space to get the clip planes. So what we do is we take the model view matrix. I wonder if I have code to do this in another project. Like the GMC probably has Frustum culling, right? Render world. Test plane Frustum. So where do the Frustum planes come from? Compute camera planes. Use glue unproject. Oh, I see. Yes, we've kind of brute forced it rather than doing it the smart Fabian way. And I don't have glue unproject in this project, in the current project, so I can't use this method. Do I have some other engine that would have Frustum culling? I feel like I've done this. I feel like I've done this before. Let's go grep -d GL projection matrix. Let's see. Yeah, I have lots of code that does this, but it's not necessarily to do with Frustum. OBBG does it. OBBG. Hey, look. Oh, let's get all this code. That's the wrong one. There we go. All right. Maybe it needs to start splitting this into separate files. Okay. So then we say compute Frustum after we do the GL translate. Compute Frustum. Okay, and then we can just isbox in Frustum. So we go to here and we say float let's put that up. Float bmin of 3, bmax of 3. Bmin of 0 equals cx origin. Bmin of 1 equals cy origin. Bmin of 2 equals 0. I don't know where you can get Windows 7. My microphone arm has just started creaking during the last couple of weeks. I don't know why. I don't know how that comes through. X 2 equals 1024. Now we say if test box in Frustum. Is that what it was? No. Is box in Frustum. Bmin, bmax. Continue. If Frustum check and box static int Frustum check let's call that culling. Frustum. And then if we press C, no, Control C. Okay, we can see the quads go from 30 to 13. Not quite a factor of 4. Okay, and then let's do a different hack. Frustum check equals Frustum check plus 1 mod 3. And if Frustum check equals 1, then we could beat the Frustum. But if Frustum check is 2, we keep the old calculation. That'll let us see what it's doing. And then this is not 0. Make it explicit. So if we cycle Frustum check to 2, okay, so like let's look straight up and then press Control C. And then if we move away, wow, it's still drawing a lot of them, assuming that's working. Okay, now Frustum checking is off. Now it's on. Turn off the fog. Okay, set the Frustum check and then move away. Let's if Frustum check is set to 2, then let's not update. Let's not update the meshes so we can move the camera away and really see what's going on. Okay, if we look straight down, then we don't draw very many quads. Like we're only drawing the one we're in. So we hit Control C and then fly away. Yeah, you can see. And then back to normal, Control C, Control C. Right, so it was only drawing in this direction. So if we now turn this way, yeah, I believe it's working correctly. It's a little subtle because of the chunking, but okay, so now that we're chunking, we can push the view distance out a bit more. Let's make the buildings a little shorter. To reduce the number of quads. That's only 10 million quads, so I guess we don't need to reduce it. Yeah, we're not hitting 60 frames per second, but we're close. All right. Checking in. Is this doing Frustum culling already? I missed a large part of yesterday's stream. I just implemented Frustum culling in the last 10 minutes. But it wasn't a very technical implementation because I just cut and pasted some code from another project. Although that in itself is kind of revealing of the fact that, oh, I could just cut and paste code from another project and just use it because it was factored in a way that wasn't dependent on the data structures of that project. It wasn't STB style, but it was still effectively usable as a modular piece. Okay, and so now what I want to do is I want to work on there's a couple things. We're not using the vertex buffers very efficiently. We just allocate a big vertex buffer for each chunk, and that limits how many chunks we can have, although we're limited for rendering too. But we allocate a fixed size chunk and populate it when we mesh. But some meshes are smaller than others. And so it would be better to somehow pack them all together into larger vertex buffers. So you could work on that. But I think the better thing to do is we had this problem where we're not prioritizing them in a smart way and not freeing up the old ones in a smart way. So I think we should change that. So what we're going to do is we're going to go to chunk. We're going to move this down in the file. Then we're going to say int idle time. So this is LRU. Alloc chunk of I dot idle time equals 0. So when we go through the chunks, and render them, before the Frustum check, we're going to update its idle time to 0. So if we don't draw it because it got Frustum called, we still consider it recently touched. And then we're going to go through all of the chunks. And say add 1. Is that max chunks? And we don't have max int, so let's just do okay. So now we should know how old chunks are. So when we try to create a chunk, we want to do this int r for r equals 0, r less than 10, less than equal to 10 equals r. We want to generate from the inside out. So we'll work in rings. If absolute of I equals R or absolute of J equals R, then we're in the correct ring. We do that. And then in make chunk, if we fail to allocate a chunk, then let's destroy the oldest one. Int LRU 0 for I 0 I less than max chunks. If chunk of I dot idle time is less than LRU idle, LRU idle equals chunk of I dot idle time, LRU equals I. Let's not go all the way up to 7FFF. Go up to 0FFF. I mean, that's like an insane number of frames anyway, so it should never get to that. But okay, so then we get here. If LRU is greater equal to 0, then free chunk. Then clear map of chunk of LRU.cx, chunk of LRU.cy, free chunk, C equals alloc chunk. If LRU less than 0, return null. If C is still null, even though we just freed up a chunk, then that's an error. Return null. Otherwise, we fall through. Okay, so now when we make a chunk, we definitely free a chunk if it's possible to free one. I think that's all the stuff we need to do to get rid of it. Clear map, does clear map free it? Oh, clear map does free it. Yeah, so I don't need to free it. It's just, all these are just dumb linear allocators out of arrays. Like, if it becomes a speed concern, we can fix that. Like we just iterate over the whole array looking for it. But the arrays are pretty small right now, 100 items. And we only do this once, at most once a frame. We only make a new chunk at most once a frame. So the amount of work this is doing is pretty tiny. Like I do try to optimize everything, but anything that happens once a frame, I don't necessarily optimize. And so then the old method for clearing the map is irrelevant, and we deleted it. But we do want this clear here, although we could just do it in make chunk. We do it in make chunk, in fact. Let's just try it, see what happens. Oh, there's a bug where we're allocating and freeing a chunk, it looks like. Wait, why is there no intervening function? Oh, there we go. Why can't I look at C? Oh, it's null. Why is it null? Why is it getting zeroed? Free chunk. Why is free chunk ever getting called right now? It's getting called from make chunk. There's two different make chunks being called. Right, I know what's happening. We're deallocating one that's in use because we never checked that it was idle time of 0. Yeah, okay. If chunk of I dot idle time does not equal 0. So what will happen is we'll go in here and we'll call make chunk to try to make a chunk out near the edge. And it'll do all the work to try to allocate a chunk slot for it. But this will fail because there are no free chunks. And then it sets has generated to true, which actually we can now switch this back to go to done. Now, just for fun, let's remove the Frustum logic and only reset the idle time if it's in the Frustum. So what this will do is it'll let it draw out a lot further, but at the cost of unloading stuff that's behind us, and then that stuff will have to get rebuilt when we turn. So let's see if that actually happens. Does not seem to be happening because I don't see it building new data. Because we see the meshing numbers change when it's building new data. Well, now it's just stuck always building new data, even though we're idle. Why would that happen? It's the same problem. How does anything ever get freed? Under what circumstance do we free stuff here? Free chunk is getting called by make chunk. Idle time is 1, so it says it's not drawing it. I might be doing this stuff in the wrong order. Hang on. Idle time. No, we increment idle time after we generate. So if we're not drawing it, see if we can get in that state again. There. Oh, except that's going to turn the camera. So this says it's been idle for 1 frame. But why has it been idle for 1 frame? Oh, because we still generate it even if it's going to get Frustum culled. That's why. Okay, so that's not. Yeah, that's just not a valid test. We just can't do that. You'd have to actually limit to only generating if they're. You have to limit to only generating ones that do pass the Frustum check. So, which we don't have any ability to do right now. So, we'll put it back. All right, so we've got that going, which means we can push out the view radius again. Which means the what was the clear map? Let's do that. Okay, let's try to generate way too many. So now it should just be limited by the radius check. And now we're very slow. Go through checking everything from when we're up here, so we get back down lower. We're rendering about half the stuff. Did I turn off Frustum culling accidentally? Or generation, or do I have a bug that it's not generating? It is Frustum culling, obviously. That's Frustum culling off. Frustum culling on. Okay, so I have a bug now where it's never generating new map things. Oh, because everything is in range. Yeah, I can't push the range check out because all that stuff is still in range. If I go far enough away, it'll start generating stuff. Hello? Why can't I move? Oh, I'm hitting the wrong key. That's why. Yeah. Yeah, okay, I understand. What is the right way to fix that? You have to prioritize close stuff over far stuff. So XY is camera position. Make junk. Camera X, camera Y. And then dist equals X plus X times 256 plus 128. Dx equals minus cx dy equals y times cy just equals dx squared. That's dx times dx plus dy times dy. Then in this code, what we want is not the one that's the most idle, but one that's idle at all. Idle time greater than 0. Or no, it doesn't even have to be idle. Okay, we want an idle one if there is one. And if there isn't one, then we want one that's further from the camera. X equals chunk of I dot cx. Well, we knew they're all allocated because otherwise alloc chunk would have worked. Okay. Chunk of I dot cx, chunk of I dot origin of x origin. That's 128. When it's camera x. Is 2 equals dx plus dy. If arg is 2 less than max dist greater than max dist, and we pick that one, and we set max dist to dist 2. So it has to be further than the current one we're generating, and we pick the one that's furthest. If LU is less than 0, return null. Maybe that's right. Not sure I even use this path anymore. Yeah, it's not fixed function, but it is immediate mode. This is camera X, camera Y. This is camera X, camera, oh, it was actually taking that, all right. It's okay, we'll just let it be. Okay, so in theory, we probably should make some debug thing that shows the chunks that are populated around the player. How do we want to do that? Okay, I know. We switch to Blue Ortho 2D. 0, I don't know, 1,000. Bottom. Let's just actually use the window scale. ap.window.size.x window.size.y 0. GL disable. Oh, well, we're doing it up here. And then And let's actually go from -16 to less than 16. In GL quads. C equals map of 31 I and 31. And then if C equals null, GL color. So here we will actually use the fixed function. Else if C arrow idle time equals 0, and we drew it this frame. Let's actually do a little hack here. Build, get that error, add Drew. Drew, then it's green. Else if it was in the Frustum, it's blue. Else float equals has to be linear remap. See idle time 1 to, I don't know, 1,000, 100. It's frames, so let's say 10 seconds, 600. And then we map that to I guess 0 to 1. And then what we do is we make it be red. RGB. Let's make that map from 1 to 0.5. And we go 0.25, 0.25. And then we say GL vertex 2I J times J plus 17 times, I don't know, 20. Is that being drawn in 3D at the, even though I asked for ortho? Yeah, because I have to do this. GL load identity, GL matrix mode, GL projection, GL matrix mode, model view. All right. So we can make that a lot smaller. And let's make them explicitly disconnected squares. And move it down. I was wondering why that's so dynamic. There's obviously some bug here in how that's not stable. It's like not correctly removing the furthest one or something. Yeah, that's why I still use immediate mode OpenGL. I use the compatibility profile so that you can use immediate mode, because it's why are none of those ever red? Oh, because we're allowing a huge jar radius, I think. And the thing is, it's not just prototyping, right? Like a debug widget doesn't need to go through vertex buffers. It's not doing enough work here that its performance is going to be relevant anyway. So yeah, so this logic is clearly still not very much right. And I don't know why. Like, it does eventually stabilize. Alright, well, it's also getting slow, so I'm going to put back the build map. Going to put back these half-size things so that the rendering doesn't get so slow while we're debugging it. So there are these faraway ones that aren't getting freed. They should be getting freed first. We're supposed to, don't we remove the one that's furthest first? And we go in LRU order. Are we picking the smallest LRU instead of the largest LRU? I think we are. I think that's the bug. Which I did wonder why. It did seem odd that the test was that it was not 0 and greater and less than. This should just be idle time greater than LRU idle. Still got that flickering at the edges that is creating and then destroying some. Okay, so I think part of that is that the rule for which ones to allow chunk radius squared I don't remember what it ended up at. Chunk radius squared is inconsistent with the drawing? No. Maybe. Maybe we have to use the same logic here. Maybe if we don't use the same logic here, it is causing that inconsistency. Seems possible. I forgot what was the value that I just replaced. Eight times 8 minus 2. All right. So let's try that and see if that makes it stable. Nope, still doing it. Let's make sure we're not limited by v-buffs. Well, they were the same. There were 100 chunks and 100 v-buffs, so it should be fine. Oh yeah, we just did the full size. Disable. Run, exit. This should be 16 now. All right, so now we're not limited by the as limited by the number of chunks. Just want to see if that changes that edge behavior where it's rebuilding the stuff. I guess the way to test that chunk radius without having increased it would just be to make this smaller. Why can't I see anything? Oh, because I'm too high. Okay, so this is more like what we might expect. Basically, it's got a cache of stale ones still stored but not being rendered. And so if we move back over them, they'll come back in without having to be real built. Yeah, okay, so this is more the behavior we wanted to see all along. And so the problem was just we didn't have a good match between the number of chunks and the radius that we were drawing. that on V. We don't support debug build anymore. And then on C, let's put chunk viewer. These should all be and then so we press C and it shows us that. Okay, that looks pretty good. Let's check that in. So now it feels like we have a more solid implementation of the larger scale city. So I think we can start to think about proc gen of the full city. And I think we're going to start that by splitting this up into multiple files. So called gen I think it's going to end up split into multiple files, the procedural generation, but we'll just start it with just generate. And then, oh, the recap I mentioned at the start. Let me see how many people there are. Wait, let's ask chat. Chat, how many of you are here don't really know what this project is because you haven't seen the streams where I've talked about what it is? And how many of you have seen? Yeah, yes, if you don't know, no, and if you do know. Sorry that that's backwards, but that's how I asked the question. And that way, if people say yes if you don't know what's going on, no if you do know what's going on, and that way I can see what the ratio is. So I am so sorry that that was backwards. Okay, there are the fraction of yeses are pretty high, so we can talk about that. All right, so here is an old project called ZMC, which stood for Zombie Mega City, which is an infinite procedural city that I didn't go very far in, like the building generator for it, but I spent a lot of time on the layout of the roads, which determines the layout of the buildings, and it's just infinite, non-repeating. How do I go fast on this one? I don't seem to be able to go fast. Yeah, that just slows it down. And this is from 2012, looks like, but or 2017, maybe. I was working on it still in 2017, so about 10 to 15 years old. And this predates STB Voxel render, which is the voxel rendering library I made that's like this, which is it generates meshes. It just generates quad meshes. It's not doing any like fancy ray tracing kind of stuff. And the procedural generation lives entirely on the CPU. The CPU sits there, generates big grids of voxels, and then figures out where the quads are and builds a quad mesh. So this new project, yeah, the Voxel project that I was working on publicly was called OBBG and was based on the STB voxel render, but this actually predates STB voxel render. I basically made STB voxel render kind of inspired by this. It was like, can I make a sort of a public version of this? So the new project, the goal is to do basically the same thing. I'm not as far along in the procedural generation, but the big difference is that the procedural generation is occurring both on the CPU and the GPU. Specifically, the CPU decides where the voxels are and the GPU generates the mesh. But it's actually even more sophisticated than that, because the CPU doesn't build a big grid of voxels and hand it to the GPU. The CPU builds, you could think of them as primitives, builds what I call a command list, that is a sequence of instructions for how to build the map. So for example, this building is built with 4 walls that are placed as big continuous walls without holes in them, and then it does a CSG subtract for each window to create the windows. And then inside all of these buildings, there's an elevator shaft core and a stairs core. And the stairs are created using a special stairs primitive, because that would be too inefficient to build them with the normal primitives, because you'd have to have a separate thing for each level of the stairs, would require a separate command. So I made a special stairs primitive just for that. But so that, yeah, that's the main thing, is that, and this may not even be a good idea, because while the GPU can build that mesh a lot more efficiently than the CPU can, the CPU doesn't have very much to do, especially if you have multiple cores. So you could dedicate one core to just generating the meshes. So if the GPU generates the mesh, even if it generates it efficiently, it's stealing time from the GPU that could be spent on rendering. Whereas the CPU can't do the rendering at all, but it could do the mesh construction. So it may be a bad trade-off to do the meshing on the GPU, but it's just a fun technical project to do it on the GPU. And then the original project that I was doing, the Infinite City, Zombie Mega City, the idea that I had in mind was that it would be a city overrun by zombies, and you would do PvE, team PvE. So teams of players would go on missions to, accomplish objectives in the city. Without any PvP things. So a little bit like Helldivers 2, conceptually. In Helldivers 2, there's this planet overview, and you pick missions in different spots. And the design for the Zombie Mega City predates that, but it sort of had the same idea in mind, that there's this big city, and you get assigned missions in different places in the city. But because it's one big continuous city in the procedural generator, you could actually potentially connect between different mission areas. So that's what's going on with this project. Is there anything I didn't explain? So this is still rasterization. So the GPU takes this descriptive list of where to place voxels, computes where the voxels actually are, determines which voxel faces are visible and which are hidden by other voxels, and generates quads for the visible faces. And then the subtlety is that every voxel is actually at most three face pairs. The opposite face, you can never see both the north and the south face of a single voxel at the same time. So each voxel is encoded as, depending on how much of it was visible, as 1 to 3 face pairs. And the face pair decides whether it should be a north quad or a south quad dynamically. You know, and you never get to backface any of them because it always, one side or the other always faces the viewer. Well, unless you're right down the side. And actually, now that I think about it, maybe I should store 2 bits for the face pair about whether each of them is enabled or not. I don't have that. I'd have to store so much extra data to propagate that through. But if I did do that, then you could get backface culling. You could cull some of the faces. Because, yeah, in the current engine, it never gets backface culling because if the south face was visible but the north face wasn't visible, it just encodes the north-south pair is visible. And it draws either the south or the north depending on which side you're on, so neither of them ever gets backface culled. I didn't really think through that effect. Need to calculate the positions. Well, it's just a mesh. So you're not really calculating the positions. I mean, I guess in the sense of calculating whether it's on the north or the south side, but I don't think that's what you meant. So for things like physics, would you just use the command sent to the GPU to generate a chunk on the CPU side? Yes. What we'll do is the CPU will take the same instructions and generate maybe like a run length description. Wow, that is really messed up. Is that because we're like really far? Is that, I was mentioning that there's the floating point precision thing. Have we just gotten so far away from the origin and that quickly? I don't see how we could have gotten that far away from the origin that quickly. X is 71,000. The voxel is 1 wide. 71,000 is about 16 bits. Floating point gives you, what is it, 24 bits of precision. So we should still have 8 bits of precision, 8 fractional bits of precision at 65,000. That's weird. It's not 21. It's 20. It's 24. It's 23 bits of mantissa, right? It's 8 bits of exponent, 1 bit of sine, 23 bits of mantissa, but you have an implicit leading 1 bit, so you effectively get 24 bits of precision. Okay, well, that's just a bug. When you're seeing that internal face, that shouldn't even be getting drawn. What is going on here? Like, it shouldn't. Oh, no, it would draw that face. That does make sense. It does make sense that that face is getting drawn. So it seems like it's Z fighting. Yeah, there's a standard thing you're supposed to do here, which is we're just directly using model view projection matrix. What we actually want to do is do this calculation in integers before it, and not pump it through the model view projection matrix. But to do that, I need to not use the model view projection matrix. I need to to actually split that up and do the model view and the projection separately, because the model view is what has the camera translation in it. Okay, if I did minus camera pause, and we take that out, we need it for this. What is this drawing? Oh, this is drawing the plane. Geo push matrix. Geo pop matrix. And then for the, we need it down here. Okay, so if I move that into the shader, I think I have a bug. What? Am I not setting the camera pause? Camera pause. Why does that not work? Oh, because we're getting the projection out of the, where did we compute Frustum? Yeah, we need it. We need it there too. Okay, hopefully that works. And now, if we go a long way away from the origin, hopefully we don't start getting this glitch. Let's see, each chunk is 256, so it's about 256 chunks that we had to go to get where we were. I should probably just print the XY coordinates. Haven't really mattered until now. All right, let's see where we are. We're at 15,000, so we have to go 4 times as long. Because I was talking for a long time while doing this. Okay, so again, prefix with nothing stew. Any more questions about what this project is, how it works, what we're doing? Wait, am I moving along the y-axis, not the x-axis? I thought x was the value that was really large. Oh, yeah. Check what x is now. Okay, it's increasing. Good. So any more questions while we fly out to see if we can get the glitch? Yeah, the infinite plane can be tiled in a non-repeating way using just one tile of a specific shape. So a project that I've been working on off and on, and I'm not currently working on, but you know, when amongst all these other projects, is a project we looked at it a little bit called Big Ships. It's a space game where the idea would be to have, it's a classic thing you want in your space combat games, is to have big capital ships. And so one thing I was working on was ways to put big ships in the game with textures how do you get the textures on them? Because if you just use a regular size texture, the capital ship will look fine from the distance, but once you get close to it, it's not going to look very good, or it's just going to have a really fine repeating texture on it. Not very appealing. So I was looking for ways to get more interesting large scale texturing. So I made a system so you can make a tile map and have a really big texture that's tile mapped. And so, yeah, I was just thinking not so much that technical side, but just like what can you do? Have like you could have an alien race that puts abstract patterns on its things, and an interesting thing might be to put a tiling of a plane that's non-repeating. And there are various ways to do that. And that particular one is interesting because it's a single shape. So it's sort of like you could almost imagine that aliens came up with it as well, because if that's the only way to do that. This is the X and Y, the Y axis is backwards in this. It's positive up, because if I turn right, it turns left. Okay, we've gone far enough. Yeah, we're at 80,000, so a little further than we were before, and it's not glitching the way it was. So that was, in fact, the bug. It was floating point precision. Anyway, so yeah, I thought that might be kind of an interesting use for it, but it might be. I decided it was a little too weird that it was like this fresh discovery, and having the aliens also have that would be weird. But I might have looked for like an older pattern, like try to find a pattern that seems kind of universal, like that you could believe in aliens might have discovered it. It was just an abstract idea. It wasn't something I actually worked actively on. Okay, so I need to flip the y-axis. Okay, any other questions? Or we will move on. It should be the same, but whatever. So now we have just barely more than the radius. What was that? Some kind of glitch? It's a hole in the mesh. Pretty sure that's a hole. Trying to see the building through it. There we are. Yeah. Okay. Is that I need something that shows me where the chunk boundaries are. Negative 479, negative 54.28. All right, so how do we debug the chunk boundaries? Guess we do a lighting effect. Uniform int show chunk. If in float if show chunk output color dot RGB times equals vec3 0.5 0.75 0. And then if show chunk, and then we'll do a checkerboard. So the checkerboard is CX, CCX, XOR CCY, and 1. And show chunk. Show chunk. If p.input.shift show chunk equals thing show chunk else. Yeah, you can use SV Voxel Render to do whatever you want. I mean, you know, doing a big city is kind of like if you look at Voxel game dev on Reddit, you'll see that nobody's doing anything like this. They're all doing Minecrafty things, or a few are doing other things. So it's a little weird to take the same idea, but I mean, I wouldn't be mad. I think you'd be better off coming up with your own idea for something different and unique than an infinite city. But maybe your take on an infinite city would be very different too. So yeah, I'm not worried about you stepping on my uniqueness if that's the thing. I think for your sake, you'd be better off doing something different. But yeah, whatever. Okay, right. So Shift C. Okay, yeah, that sure shows the boundaries. A little more stronger than it needs to. And then we go to go to where we translate, and then we change x to negative 479, and we change y to negative 5428. And is that at a chunk boundary? It is at a chunk boundary. What a surprise. So across this chunk boundary, we're not computing the right thing. Yeah, because when it generates the 10 by 10s around things, we don't get the commands for the neighbors. So it doesn't generate the correct 10 by 10. So why are these not totally broken everywhere? Like here it's because the height field is a special thing that we don't know how to compute the neighbors for, which is actually fixable. But there's also a default behavior that we can have, which is just to always show the faces at the boundary, which we probably should implement that. Although, wait, I did say that I want to be able to have you generate chunks that start off the edge. So we want to change the height field from 1717 to 1919. Yeah, it needs to go one further. It actually only needs to go 1818. It's kind of subtle. And then offset by 1. And we need to do the same thing in the texture. And then in the map builder, this needs to be 18 by 18. And we go from -1 to 16. We offset this by 1. And then we update 18 by 18. And when we allocate it, it needs to be 18 by 18. And these should all be pound defines. Don't do it the way I'm doing it. Okay, does the basics of that work? No. We totally broke it. Mesh buildings that get voxelized stuff. Yeah, that's fine. Do you use Glad Glue or some GL loaders? No, I use a custom system. Like I said, yeah, I'm not worried about the encroaching. You know, if that's where your muse takes you, that's fine. No, I use my own thing, which I don't have to use Windows.h, and I don't have to use OpenGL.h. I have a replacement for all that. So let's see. So yeah, here's where I build my OpenGL stuff. And then I have my own definitions of this font is a little large, so for streaming, the font is slightly enlarged, which is why it scrolled off the right edge there. So I have all my own definitions for those things. Then I also have a floating point library, or a vector math library. And then let's see, where do we do the Windows stuff? And here's the replacement for windows.h. So it's just cut and pasted basically from Windows, all the Windows headers that I use. And then a similar thing defining all the functions. So this macro is used to, in the same way for the OpenGL, the macro is used to define function pointers and to get them from a DLL, to load them out of a DLL. And it was just to avoid the dependency on all of those things. It's not very much time. It's spread out. Like every once in a while, I'll use some OpenGL function that I haven't used before, and I have to add it, and that takes half a minute to add. So if we added up all those half a minutes, that's probably a couple hours. But I've run into various friction things with trying to use the extensions directly, and I generally can't use things like those loaders because I'm using VC6 and most things don't support old Visual Studio compiler. Okay, so let me check in what I've got. Okay, and now we have good mesh, good chunk distribution loading. Oh, right, so it's starting to split into multiple files. So we'll have a generate file, and we'll have a render file. So start with render, go into main. Pass in the camera. Why is it saying I haven't defined it? Oh, I still have that one. Why is it not getting that from STB platform? That's good perspective. Oh, because it's not. I never added it to this. even know what toggle was. So these all want to be globals. That we want to bring over. Chunk. Okay, this doesn't need to live inside the renderer anymore. Oh, but it does need to use chunk radius. Okay, yeah, we need to move all these. All this stuff needs to be done differently. But for now, we'll just... Okay, yeah, I changed this logic. I can't answer that question. If somebody else in chat wants to, they can. I have no idea what's going on here. All right, well, let's leave this logic the way it was instead of changing it. Oh, no, why is the ground mesh broken? Oh, did I never finish fixing that when I was changing everything to 18? Did I not actually finish doing that? Did I switch back onto this task without finishing that? I probably did. Build texture grid. I got so lost about what I was doing. Height field. We did do that fix. All right, let's put this back. 17 by 17. 17 by 17. Zero, zero. 0, 0. 17 by 17. 17 by 17. 0, 1, 1. 1, 0, 1, 0. Oh, the binding was different. I cut and pasted between them, but the binding is different. Height field. That would be my guess. Bind it to 3 for this one and 6 for this one. Yeah. There's a build texture grid. This needs to be on 6. Yep, okay. All right, so I've successfully moved the file, the rendering over into another file. Why does this get so slow? I guess maybe I can't trust it because of OBS. So I'm trying to think, maybe that's a stopping point. Why am I moving? There's no momentum in this. You have to press a key to move. How is it moving spontaneously? No, it's not, because I touched a key. It's like the key got remembered stuck down. Weird. Oh, it happened again. It's like I'm losing up-down events. Maybe the window went out of, maybe the mouse went out of the frame while it was held down. Yeah. If I hold down W, move the mouse out of the frame, let go of W, then we lose the up event. So yeah, I think maybe that's a stopping point because I'm sleepy. Um, so let's take questions. Although we were just taking questions. Check in. Oh, I have something running in the browser. I had some dumb thing in the browser that's probably been affecting the performance the whole time. Why is my check-in taking so long? I shouldn't be slowed down by anything. Good lord. This is like we're grinding files somehow. I don't know. I mean, it was working fine a second ago. Maybe it was because I was running this while I was checking in. Oh, I didn't actually check that fixed the bug. Main. X is negative 479. Y is 5428. Why am I inside a building now? Oh, because I didn't negate it. Oh, nope, it's still there. So I didn't fix it. So I don't know. I'll have to investigate. Because I think that should have fixed it. Because I'm allowing it to know what the height field is outside of the 256 chunk, which is it needs it so that it can know that this voxel is open, so that it knows that it needs to generate that face here. Any experience advice relating to persistent data structures in C? No, I've never used any. I'm really only familiar with them from garbage collected languages, and even there I've never implemented them, but I'm aware of them. We mentioned, I don't know if anybody was around for this many weeks ago, mentioned the functional data structures book. Which was all persistent data structures, I think. Or at least some of it is persistent data structures. Because they're very natural in functional programming. I'm just curious if anybody remembers that discussion. That's not quite. I'm not sure if that's actually the title of the book. Something like functional data structures. But if nobody was around for that discussion, then it doesn't matter. You'd say one thing I don't know about programming. Without knowing more about you, that's hard to answer. And it's also too big open a space for me to like think of anything specific. Like there's too many. Like my brain isn't finding anything because it's not in there enough space. That's assuming by persistent data structures you meant not just persisting them to disk, but I think that the term refers is a jargon term for data structures that you can access them from different time states, basically. Persistent data structures that preserves the previous version of itself. Yeah. So like you get a handle to a hash table, a dictionary, and you always generate a new one when you modify it. And so if you keep the handle to the old one, it remains valid, which is very natural in a functional language because you don't normally modify things. And so if the data structure itself is immutable and it's garbage collected, then as long as you keep a handle to it, you have a persistent data structure. Yeah, I mean, how to do undo is kind of a different question. I mean, I guess you could use persistent data structures. Yeah, I only brought up the disk to disk because a reply sounded like maybe they thought that's what that meant. Um, Somewhere I saw recently, I saw a taxonomy of strategies. Like one strategy is you just take your whole data set and make a copy of it every time you change something. And then if that's too big, you can do that, but you do it with a delta. You do some kind of delta compression of it. And I think that's what the persistent data structure idea is getting at is what's the efficient way to do that. But there, you're kind of doing it at a data structure level where the data is live in all its forms. Whereas the normal thing in an undo system is that it's more like serialization a lot of the times. You serialize into memory and then you can unserialize to get it back. Although you need to maintain pointers and like undo deletions and stuff like that, so it all gets a little more complicated. So certainly the persistent data structure model would be viable, but if you're not working in a functional language, I'm not sure it's the best approach to that. So then the other approach to undo that I know of is that you view it as every operation you do in your editor is a command that you've abstracted out as an operation, and you have an undoable version of it. So like if what the command does is it modifies some field, then as part of that you save out the command to modify the field back the way it was, and you save that out as part of the undo state is generate that command. And you just do that all the way through, and deletion corresponds to creation and vice versa. So undo, and that's often a good way to design an editor because you like want users to be able to bind things to keys or to do them in menus or whatever. And so if you just make every operation a command that is its own isolated function that are triggered somehow from various places, that's natural for the editor UI, and then that gives you a starting place to do undo redo. But certainly the fast thing to do, like that's bug prone because now every single command you have to think this through and get it right. Whereas if you use serialization or a persistent data structure, then it just works without you having to worry about getting bugs in individual operations. Are mathematical operations on floats even reversible? No, you don't. You save what the result of the reversed operation is. You don't save the operation. So if the operation adds 1, then what you store in the undo log is not subtract 1. You store in the undo commands. You don't store subtract 1. You store in the undo commands set the value to x, where x is the old value. So those are the methods I know of to do undo and not. I still haven't answered Carrot Stick's question. An interesting thing about programming, or whatever it was. One thing I don't know about programming, is what he asked. Yeah, so then the problem with deleting object is you need to be able to undo it. So you have to persist it in some form. And you don't ever, you keep it forever. I mean, if you have infinite undo, then you have to keep it forever. If you have 99 levels of undo, then as soon as it's 99 old, you can delete it. The interesting thing about programming, it's just so, I just can't. Okay, here's a piece of programming wisdom. I don't think it's surprising when you express it this way, but this isn't quite true. This is true in the system programming languages that I use. It might not be true if you really have a user of virtual functions. The source, almost all bugs are associated with a conditional expression. So what I mean by that is like a fence post error. Your loop runs one time too many or one time too few is related to the conditional expression of how the loop terminates. If you write your loop not with as a while loop, but if you wrote your loop as a, iterate from 1 to n, then there's no explicit conditional. It's this implicit conditional when you get that wrong. So in a language like Python, this might not be true. But in the more systemsy language where you do actually use conditional expressions for that kind of thing, it is true. And the reason why that is the case, there is like a reason why conditional expressions are the source of all bugs, is that your code mostly works. Like when you're running code, you've got a thing going, you're working with it, it basically works, and you find a bug. That bug isn't always happening. It's not happening on every iteration. It's only happening once you do something. And so maybe it's a subsystem that you don't exercise at all, in which case it could be anything. But if it's a subsystem that you do actively use, then there must be some code path that you're taking or some set of data that you're operating on that is now unique and it's triggering the bug. And that means to get there, you kind of needed to do something on a conditional. So there's a sort of a fundamental reason why you would tend to see it with conditionals. Like you can't get there without a conditional. But there's also like the specific things you can start to point out, like fence post errors, that you can explicitly see them associated with conditionals. And so one thing that means is that if you can write in a coding style that has fewer branches and fewer conditional expressions, you're likely to have fewer bugs. So for example, in GPU programming, you don't tend to have those kind of bugs. You can get the math wrong and get like stuff wrong, and you can get all the setup wrong and you get a black screen. But in terms of like something goes wrong once in a while, like you don't tend to get one wrong pixel. There are definitely cases where you do get one wrong pixel, but it's not the normal thing when writing GPU shaders. And that's because GPU shaders just aren't doing conditional expressions the same way most of the time. Do I have a favorite file format? Not really. Sure, I have a favorite file format. It's the audio codec that I wrote. It's not public. But if you have an Unreal license, you can look at it. It's not technically a file format, though. It's a stream format. Yeah, I hate Collada. Some bugs happen because you're missing a conditional. Yeah. Which, like, if you're not hitting the bug most of the time, and then you hit the bug, and it was because you didn't have a conditional, then yeah, it's just like you didn't handle a case. But there's so yeah, I could argue that that's still associated with conditional. It's it's associated with the conditional that you haven't implemented yet. But yeah, I mean that's a little fuzzy. It's certainly not the case that all bugs are associated with conditionals. It's just an observation for the class of bugs of like it's hard to debug, right? Like, or it's a like if you have a math error, then the math error probably just gets everything wrong in all cases, and you see it immediately. It's not hard to know where the bug is, whereas any bug that's more subtle. Fence post error though is an interesting case because it's always wrong. You're not getting it wrong every iteration, but every loop has one wrong iteration. So that's still a case where it's happening all the time. I don't know. I mean, the point here is that I'm sort of arguing that there's an abstract reason for it, but it was actually a practical observation. I observed over 10 years of programming in the 2000s. I started to notice, you know what? Most of my bugs are associated with a conditional expression. And so if you can find ways to express things that avoid conditional expressions, for example, iterating loops without using a conditional, those tend to be less bug prone. You can still get a fence post error with a counted loop, but you know, if you iterate for I over the contents of a container, I is or item over, you know, for item in container, you're just not going to have a bug there, right? The bug of the item goes through all the elements in the container. It's just going to happen. So to the extent that you can find ways to express things that avoid the conditionals, you're less likely to have bugs. That's the observation. Okay, any last questions? Short stream, only 2 hours, but we got some stuff done. What did we get done? Better chunk tracking. Better chunk tracking generation logic. Chunk debugging. Split rendering into own file. Might have done something else, I don't remember. Oh yeah, Frustum culling. Probably been asked a million times, what do you think of Vulkan? I've never coded to it because it looks so gross. The amount of boilerplate you have to do. And also, as we talked about here with this chunk debugging stuff, immediate mode is just really convenient. If you don't have immediate mode in your graphics API, make yourself an immediate mode like wrapper that lets you do quick and dirty stuff. And so, yeah, Vulkan doesn't appeal to me because it's the same shaders, but without immediate mode and with all this boilerplate. So, no reason to even try it. as long as new operating system versions continue to support OpenGL, I'm going to stick to OpenGL. It might be if I shipped a game that would turn out to hurt. I don't know. Any final questions? Three, two, 1, 0. Nobody. I'll give it another couple of seconds in case somebody's in the middle of typing. All right, we'll call it there. So thanks everybody for watching. Voxel week will continue this week. And maybe next time we'll actually start doing the road network procedural generation. But I don't know. And maybe I'll stream tomorrow. I don't know. My schedule is slipping around, so I don't know exactly when this will happen. But all right, that's it. Thanks everybody. See ya.